Alrighty, today we are finishing section 5.1, okay? Things will pick up a little bit here, but let's put that away. Let's go through answers and questions from the homework, and then today's going to kind of be a work day, just doing more and more and more and more examples, okay? Because really that's the only way you guys are going to get good at these is just to do them. So, but let's first of all start with some answers. Let's run through. This was from the, I had given you the vocab check from Monday. So let's just run through these. 1 over cosine is?
Secant.
Secant. Come on. There we go. Secant. Cosine over sine is? Cotangent. 1 plus what is secant squared?
No, cosecant squared.
Tangent squared. Okay. Cosine of pi over 2 minus u is? Sine of u.
Wait, can we go back to number 5 for a sec? So if you had 1 plus cotangent squared, what would you get?
Cosecant squared.
Okay.
And if you had 1 minus?
If you had 1 minus tangent squared, you'd have to do some stuff to it.
So then
simplify.
Is there like a property with the tangents or cotangents and one that'll get you sine or cosine?
Wait, I don't understand.
I'm just trying to understand like the rule, because the 1 plus the tangent gets you secant, which is in like the other.
Remember, this we developed from sine squared plus cosine squared equals 1. We divided everything by cosine squared. So the sine squared over cosine squared was tangent. Cosine over cosine was 1. And 1 over cosine squared was secant squared. And then we developed the other one by dividing everything by sine squared. Okay. Alright, tangent of negative u.
Tangent of
Negative tangent of u.
I was close.
Okay? Remember, the only one where the negative doesn't matter is cosine and secant. Okay? The others will make the value negative. Alright, 1 over cotangent is? Tangent. 1 over sine is?
Cosine.
No, you're right, cosecant. Alright? By the way, make sure you know the abbreviations. Some of you on the test, which I'll be getting, I'll be giving back, those of you who took it originally, I'll give you those tests back today. Some of you are writing COS for cosecant. Alright? COS is cosine. Alright? And I think you were thinking the right thing, but got one wrong there because you had the wrong notation. Okay? CSC for cosecant. Number 6, 1 plus cotangent squared is?
Cosecant squared.
Good, cosecant squared. How about cosecant of pi over 2 minus u? Secant of u. And cosine of negative u? Yeah, it's the same as cosine of positive u. Alright? Remember, for cosine and secant, the negative doesn't matter. So guys, really, you need to get to the point where you could whip through, 10 like that in no time. Okay? You've got to really know these well. So, can't emphasize that enough. Alright, yesterday we had looked at 1 and 2. Were there any questions on others from 1 through 9, the odds? Or actually 1 through 13, the odds?
11 and 13.
11 and 13, okay. Alright, so let's see, number 11, I'll just rewrite it over here. Tangent of theta equals 2, and sine is negative. Okay. first of all, which quadrant do we have to be in?
Tangent. Three.
Third quadrant. Tangent's positive, but sine's negative. That only happens in the third quadrant, because remember, sine is negative here and here, tangent is positive here and here, so we're in the third quadrant, okay? And I'd recommend, draw a little thing like that. If you're having trouble picking the right quadrant, do something like this, okay? Where is tangent positive? Where is sine negative? Where do those two overlap? That's the quadrant you're going to be in. Alright, so now that we know tangent is 2, where could we go from there?
To cotangent.
Okay, start easy. Cotangent is a half. So
And then you know that cosine is 1 and sine is
Okay, it could be 4 over 2.
2.
Yeah.
Not- yeah.
Never mind.
see, that's the thing. Sine can't be 2.
I lied.
Negative. Negative.
You gotta use one of the Pythagorean properties.
There we go. We got to use one of the Pythagorean identities.
Oh, the cotangent plus 1.
Yeah, you could do the cotangent one or the tangent
Tangent's
one.
gonna be nicer.
Okay. So what was it? 1 plus
1 plus 4
Tangent
equals.
yeah, 1 plus tangent squared, which is 4, equals
Secant
Secant
squared.
yeah, secant squared.
Secant
Okay.
is 5.
So that's 1 plus 4 equals 5. So secant equals,
2 point.
it is 2.2. You can just use radical 5 though. Now question, is it radical 5 or minus radical 5? Because algebraically when you take the square root it could be either one.
Well, sine is less than 0, so it's negative.
Yeah.
Yeah, but secant's related to cosine.
Never mind, I read it wrong. I saw S real quick.
That's okay.
It's gonna be.
It's negative.
It's negative.
Why
It's
negative?
cosine, it's
Because
negative.
both
It's
sides.
negative.
Because cotangent is 1/2 and not negative 1/2.
Okay. Remember we're in the third quadrant, right?
Sine's negative in the third.
And
quadrant.
sine's negative, cosine is also negative in the third quadrant, and that makes sense because when you do sine divided by cosine, you have a
It's
negative
positive.
divided by negative to get your positive tangent. Okay? So now that we know secant,
Sine is gonna be negative 5 root 5 over 5.
not sine,
Cosine.
Cosine.
Yeah,
cosine. Okay, cosine is the reciprocal of secant. So 1 over root 5 is a negative root 5 over 5, simplified. Okay? So now all we have left is sine and cosecant. Any ideas?
Sine is
Tangent
negative
squared
1
plus
over-
1.
Yeah,
So
tan,
it's
1
5.
plus tangent squared is.
No, 1 plus cotangent squared now we would do.
Okay, we could use a similar thing to this, 1 plus cotangent squared equals cosecant squared, or
If you have cosine and secant, can't you just find the. Just put.
1 over.
Find sine and cosine?
No, 'cause
secant
1
and
over
cosine are
cosine.
reciprocals of each other.
Oh, you could
Oh,
set, you could
They
set,
like getting
um,
so lost.
you could set it equal to tangent, with the sine over cosine.
Okay, yeah, that, and honestly, that's probably what I would do. You could do it with the 1 plus cotangent squared equals cosecant squared, or you could just say, hey, tangent equals whatever the sine is divided by the cosine, negative root 5 over 5. Okay,
So then 2 times negative root 5 over 5.
Yeah.
yeah, so sine, we just multiply both sides by that cosine, so it's a negative 2 root 5 over 5. Okay?
Oh wait, no, negative 10 root 5
Yeah,
over
it
5, 'cause
has
it was
to be
5
negative.
root 5.
No. This, when you take the reciprocal,
The
2.
Oh, yeah, because it was a
The 2 is
one on
equal.
top. Yeah.
Yeah, it was
Yeah.
just root 5 over 5, so this is 2 root 5 over 5. And then you can get cosecant by taking the reciprocal. So cosecant is the reciprocal of that, so negative 5 over 2 root 5.
How did you get 2 for tangent?
They told us
Given.
that. That was a given.
But then it shouldn't be like 2 point something.
What do you mean?
Because square root,
Well,
2 square root of 5 is not.
technically the square root of 5 is 2.2 something, okay? But don't, just leave it in terms of radicals, okay? Secant is negative because we determined we were in the third quadrant, and secant is the reciprocal of cosine, and cosine is negative in the third quadrant. So if that's negative, then secant has to be negative.
So this cosecant root 5 over j, negative root 5.
Yeah, you would you'd make it negative 5 root 5 over 2 times 5 or 10. So that does simplify. That simplifies down to root 5, negative root 5 over 2. Okay? I know we don't have our answers organized real well here, but there's sine, here's cosecant, here's cosine and secant. Okay?
Cosecant is undefined.
Alright. So does number 11 make
13.
sense now?
Yeah, can we do 13?
Yeah. Okay. Well, let's think about this. Number 11 is actually easier than you might think.
11 or 13?
13.
13. Okay. Let's get rid of all this. Okay. Now let me ask you a question. What makes something undefined?
When it's 0.
0.
When it's divided by 0.
When it's divided by 0. Okay? So, that's bad. Cosecant theta is something divided by 0.
So it's
I'll just put 1 divided by 0 because it doesn't matter. Okay? So what does that mean? What? Sine is what? No?
No.
Sine is 0.
Sine is 0. There we go. If we flipped that, we would find sine to equal 0.
Oh, and then cosine.
Alright? Now at this point, you
So
could use
tangent
what
is
you
0.
know. Hang on. So at this point, you could use what you know about your unit circle. You could even get the angle. We know cosine is going to be negative. So where does sine equal 0? What angles?
Pi and 2
Pi, 0 pi and 2 pi. Which of those has cosine negative?
Pi.
At pi. Okay. This is one that was a little bit more challenging in a sense because it wasn't in a quadrant, it's actually a quadrantal angle. It's that angle pi. Okay? So, this is undefined. Cosine is negative. What does it equal there?
Negative 1.
-1, which means that secant equals -1, because the reciprocal of cosine, or the reciprocal of -1 is -1. And then, what does tangent equal? 0, because 0 divided by -1 is 0. And then what would cotangent equal?
Undefined.
Yes, it would be undefined, because the reciprocal of 0 is undefined.
How do we know cosine is negative
We know that one actually from our unit circle. Okay? We know it from our unit circle because sine is 0 at pi. Okay? But actually we can get it even without using our unit circle. Because remember, sine squared plus cosine squared equals 1. Okay? But sine is 0, right? So that means cosine squared equals 1. So if I square root those, then I know that cosine equals either 1 or negative 1. And since we were told that cosine's negative, we know it's negative 1. Okay? So we didn't have to use the unit circle, but if you remembered the unit circle, it actually made this problem easier. Okay? All right. Let me give answers for these next two sections, and that was all the homework.
What are all the Fs?
All the
On the-
Fs.
Yeah, on the side panel where it's got the previews for the next
Oh, that's
phases.
because I have timers. It's like a flash
Oh.
app that's built in, so it just shows up. Yeah.
Yeah, that's what I'm saying. This is poor student work.
Here, examples of poor student work. That would be kind of cruel.
It's something Mr.
All right.
Ross would do.
So 15D, okay. Cotangent squared minus cosecant squared is going to be negative 1b. Sine of negative x over cosine of negative x is going to be e negative tangent. Okay. You can think of that one of two ways. Sine of negative x is negative sine of x, and cosine of negative x is cosine of just positive x. So a negative sine over cosine is negative tangent. Or just think of this as, hey, that's tangent of negative x. So that's negative tangent. Alright, number 16, tangent times cosecant, that's sine over cosine times 1 over sine. So the sines cancel out, you have 1 over cosine, which is secant. And then number 18, this is sine squared times 1 over sine, so that reduces down to just sine. And number 20, this is cosine of x, this is sine of x, cosine over sine is c, cotangent. And again, you could have done this two ways. Either calling this cosine of x and calling the denominator sine of x and then cosine over sine is cotangent. Or you could have said, hey, that's tangent of pi over 2 minus x. Well, using my cofunction identity, I know that is cotangent of x. Alright? Alright, any other questions on 15 through 20? Okay. And we don't have our phones out because this is already a challenging enough section without distracting ourselves, right? Alright, that's what I thought. Alright, sine times secant is sine times 1 over cosine. So that is sine over cosine, which is b tangent. Okay, number 22. Secant squared minus 1 equals tangent squared. It's 1 plus tangent squared, so if you subtract the 1 from both sides. So this is tangent squared. Okay, tangent squared is sine squared over cosine squared, so the cosine squareds will cancel. So that's just c, sine squared. Okay. 23, we have secant to the 4th minus tangent to the fourth.
Could you help this one out?
Yeah, this would be a good one to write out. What I would do with this, you got a couple options. The most simple way to do it would be to factor it. So I have secant squared x plus tangent squared of x, and then that's times secant squared x minus tangent squared x. Okay? So it factors into conjugates because it's difference of squares. Okay? Now at this point, you know that 1 plus tangent squared equals secant squared. So if I subtracted the tangent from both sides, I'd have secant squared minus tangent squared equals,
Equal to minus 10.
Yeah, you lost me.
this is where you guys really have to know
So
these.
one of them is equal to 1, the second part is equal to 1.
If I subtract tangent from both sides, I have secant squared x minus tangent squared x.
Got it.
So this is 1.
Wow.
So our answer for 23 would be F. Okay. Which if you really wanted to, you could use this again and just make it 1 plus 2 tangent squared. But you don't have to. It's not one of the choices. Okay? Alright, cotangent times secant. Cotangent is cosine over sine times the 1 over cosine. The cosines cancel out. So you have 1 over sine, which is A cosecant. Number 25, secant squared minus 1. What does that equal?
Tangents.
That's tangent squared. Good. So tangent squared x divided by sine squared.
So it's
Can you
just,
get cosine?
it's 1 over cos.
Feel free to write it out. Sine squared over cosine squared. Instead of dividing, write it as 1 over sine squared. Right?
Yeah, 1
So C.
So 1 over cosine squared is
secant squared.
E, secant squared. And then 26. I'm going to guess that it's D, because that's the only thing left. But, just to make sure, cosine squared of pi over 2 minus x, what does that
Sine
equal?
squared of x.
Yeah, that's sine squared of x over cosine. So I'm actually going to split this up to be sine times sine.
Over.
So I'm going to use one of the sines. This is our tangent, and then I've got a sine left over that tangent is multiplied by, so it is in fact choice D. Okay? By the way, if I ever give you a matching section, don't just use process of elimination. I don't follow the old every answer gets used once and only once rule. Okay?
That's cheap.
No, that tests to see if you actually know it or if you just get a freebie for the one that you didn't
Well, why
know.
not give 6 choices and only 5 questions?
Well, I might do that too.
Oh, okay.
So you at least have a 50-50 on the last one, but so.
I think the every answer can be used like more than once is cheap. Because like I've seen teachers like use like the same answer 4 times.
Well, in college, I didn't take this class, but there was a professor in college who on the psychology, go figure it was a psychology exam.
Psychology subject
Everything
is
was
The
like the
final,
same
the
answer.
final exam was 50 questions and every answer was the same. I forget what it was. but-
They did that on my final exam for algebra 1. The correct answers were Christmas tree, and I got 100 on it, but I Christmas treed it. And then as I was filling out the answers, and I called the teacher over because I was like scared, like this is a perfect Christmas tree. Did I screw up?
You got to be confident in your answers to put the same to do that. So, but anyways, all right. Are there any questions on these before we give you time to work on some?
Are we having quiz class?
No. Okay.
No quiz class?
Yeah. What we're gonna do, and I'll put a note on the blog. We're gonna bump that to Tuesday instead
Cool.
because of still having issues with a lot of people getting back here later than they expected. That'll give them more time to catch up, but also I wanted to be done with section 2 before we did the quiz. So we'll be doing section 2 tomorrow and Monday, and we'll be ready for that.
Yeah.
That's right, there's no school Monday, so it'll just be, we'll be doing section 2
It's a
tomorrow,
holiday on Monday.
but
Martin Luther King.
So,
No.
anyways. What I do want to do today though is finish what I had originally planned on doing during that's not you,
Okay.
during the fusion day. Come on.
Are you getting our test back today?
Yeah, I'll give them back to you once we break up. If you have questions, you can ask on those. All right, so what I want you to do here, page 357, 28 to 68, the evens, 93 to 96 as well. And I'll go ahead and put it up here on the,
8 to 68? That's so much.
remember homework is not graded, okay? I'm just giving you tons to practice with, okay? So no one should be sitting here at all this period saying, oh, I finished, okay? Because there's no way you're going to finish all of these in the time we have left. And that's okay. So that's what we're going to do here. I want you to break up into small groups like we did before and practice. Practice, practice, practice. That's all these take.